for question 2, we have to show that 4 sine double angle plus 3 cos double angle minus 3 sine theta minus 3 equals to this answer. So we will start from our left hand side here. We will start writing 4 sine double angle. Write out the questions that we want to simplify. We will start from our left hand side and then we go to the answer right hand side. So you can compare. So as we compare the answer here, we have our sine. There's no change, but obviously our data, they already changed into the single data. So it means that we have to simplify our double angle here and try to manage to achieve to this answer. So our first step, we are going to apply our double angle formula. So for sine 2 theta, it will be 2 sine theta cos theta. Meanwhile, for cos 2 theta, we can apply 1 minus 2 sine square theta. Why we apply this? You can see we are going to try to simplify so that each term of it consists of sine theta that we can see in our answer. Sine theta already factorized out. So we try to maintain it to sine in terms of sine. So that's why for cos 2 theta, we will choose 1 minus 2 sine square theta. And then we simplify it, we can get 8 sine theta cos theta in our first term here, and then plus 3 minus 6 sine square theta, and then minus 3 sine theta minus 3. So you can notice that our constant of 3 will be eliminated as 3 minus 3 will get 0, and then we can start to factorize out our sine term. So we factorize our sine theta here, and we can get 8 cos theta. And then minus 6 sine theta minus 3. So we managed to show our answer here. So what is important concept we apply here will be our concept of double angle, which is double angle for sine 2 theta and double angle for cos 2 theta. And another concept is we factorize and get to the answer the question asks us to show here. Then, by using this part of result, we have to answer part B, where we're going to express this 8 cos theta minus 6 theta in terms of R cos double angle. So R cos double angle here is theta plus alpha. So we will take this part and we express it into the single terms of trigo. So do our expansion here, where cos theta minus 6 theta, let it to the form that we want to expand. So it will be R cos theta plus alpha. So expand our compound angle R, it will be cos A, then cos B, plus will become minus sin A, sin B. And we expand it fully. So that we can come to the result of comparison here to come out two equation, and we want to solve what is our R and what is our alpha here. So bear in mind the question here, they say R is positive value and alpha is an acute angle in radian. So we have to put our calculator in the mode of radian. Now we're going to form out our two equations as we compare here. Cos theta, sin theta with the term of sin theta. So the coefficient for cos theta, the coefficient of cos theta, which is r cos alpha, will equal to the number 8. There will be first equation. And then second term here, r sine theta, coefficient for sine theta is 6. So r sine alpha here will be equal to 6, second equation. Then we try to simplify these two equations in order to find out what is our r and what is our alpha here. So the equation we can simplify here, we're using equation 2 divided by equation 1. At the same time, we eliminate our r, we get our alpha in tangent. And move our tangent to the right hand side. So please set your calculator mode into the radian before we calculate this arctangent 6/8. So shift your tangent and then 6/8. It will give you a radian answer. So our radian answer here will be equals to 0.6435. So in radian as the question asks us. Then we continue for solving our r. Then we'll take the equation 1 square plus 2 square. At the same time, I factorize out my r terms. So at this square here, my r square I take out, leaving here is sine square alpha plus our equation here as I take out r square is leaving cos square. So value will be 6 square plus 8 square. So r square will be equals to 10. So our r only receive our positive number, so square root 100 will equals to 10. So that will be our answer. So finally, we managed to express our r cos theta minus 6 sine theta equals to r, which is 10. We plug in our answer. And then cos theta plus alpha. So alpha is 0.6435. So what is important here, you can see, for the first part, of course, our expression using our compound angle cos. So cos A plus B, make sure you expand this correctly using formula cos A cos B minus sin A sin B. Operation plus, it will become negative. So this is our expansion. As we can get this expansion correct, then we can build out our two simultaneous equations in order to find out what is our unknown r and our unknown alpha. So solve the equation, then we can get these two answers. So finally, express it in the format as the question asks us to do, which is r compound angle theta plus alpha. So this is our 5 marks here. Then we're going to see the next question. They say use the result A and B. We have to solve this. So we have to solve this for the data in between 0 and pi. Means we solve it in the mode of radian. So give your radian correct to 3 significant figures. So this is the equation that we given from part C, question C. So we apply our facts in A and B. So we try to get back our part A form, which is 4 sine 2 theta. We move back our term to the left hand side. So it will plus 3 cos 2 theta and then minus 3 sine theta minus 3, that will be equals to 0. So from this part, we already put proof in part A, where this part A is equals to the term of sine in the bracket of 8 cos theta and then minus sine theta. So this is our part A result. And then from the part B result, we express the term of 8 cos theta minus 6 sin theta into the R compound angle, which is R cos theta plus 0.6435. So you can notice that our equation here now is in factor form, where our first factor we can read out is sin theta equals to 0, and then another factor is here, 10 cos theta plus 0.6435 minus 3 equals to 0. So this, we simplify it, we can get cos theta plus 0.6435 equals to 3 over 10. So this is our solution, we get it. And now we're going to start to solve for the angle. So to solve for the angle, we must have trigo angle value. So trigo angle value, both of them are ready to solve. So we will going to apply our 4-step here. So for the first part, our range here is theta between 0 and pi. So I can use here. And then quadrant. For 0, I assume the quadrant to be positive. For 0 signs, I assume the quadrant will be positive. It will be quadrant 1 and quadrant 2. And then we find for the basic angle, then we'll go shift sine 0. So when we have shift sine 0, it will give us 0. So means here is 0, here is 0. So as our basic angle here is 0, means no angle have been made here. So this is our answer. Our answer will be on the boundary of x-axis here. So as we can see, what is our angle is on this boundary. Our theta will be start from 0 and then until 0 until pi. So bear in mind here, our questions is asked us to answer in pi, so we cannot put in degree. So 0 and pi radian in the answer of radian. Then we continue for second part, which is our second solution here. So definitely is radian is different, its angle range is different, so we have to restart. The angle already plus 0.6435. So here 0.6435. So when our pi plus 0.6435, so it will get us up to 3.7851 in radian. And then we do our step 2, where our cos positive. Cos positive, it will located at quadrant 1 and quadrant 4. Then we continue for our step 3, which is basic angle. We will shift our cos to the right hand side. So bear in mind your calculator still in radian mode. So here they can give us in answer radian 1.2661 radian. Give more decimal before we go to the final answer. Final answer only we do the rounding. So you can see our radian is at there. Then number 4, we try to rotate our answer. So theta plus 0.6435 in quadrant 1. So they will start from 0.6435. But in quadrant 1, it is 1.266. It is beyond it is inside our range here, because we start from 0.6 and we reach here 1.2. So this quadrant is in our calculation, in our solution range here. So in first quadrant, the angle will be take is 1.2661. Quadrant 1 as is same is basic angle. Then go for quadrant 2, we don't have. Quadrant 3, we don't have. Then we go for quadrant 4. So once we go to the quadrant 4 here, means this angle is going to take 2 pi minus 1.2661. So you can notice that it is equals to 5.0171. So it is exists out from our maximum range already. Our maximum range can go in our rotation is up to 3.7851 radian. So as it rotates until here, when we take 2 pi minus our basic angle, it gives us 5 point something. So it already more than our maximum range. So this answer will not be accepted. So only the answer involved here will be in first quadrant. So the last step, we're going to simplify. So for this 1.2661, we will minus 0.6435 when this move to the right hand side. So our final answer here will be equals to 0.6226. So we look at our questions here. The question asks us to put our answer correct to three significant figures. So it will be 226. So when it round off, 26 will become 3. So this will be our final answer. Conclusion, our data involved here will be 0 and then pi 0.623 radian. So what is important here? So of course, from the first part, we apply the concept from part A. Then for the second part, we apply our concept of part B, and then we get to our two solution value, which is 0 and this 3/10. So for this part, solving the basic angle, we get these two answers. For the another part here, we simplify it to the three goal angle value, and then we find out its basic angle and get to the correct rotation and the answer. So this is how we solve our trigonometry equation to give you 7 marks here.